So Andy made a comment about being able to send someone a link and launch an application directly from the web. And as a means of advocating PhoneGap, I'm here to tell you that you don't need PhoneGap to do this, right? And there's a lot of cool technologies with HTML5 that will enable this. Now, you're not going to take pictures with your phone, but in the space of enterprise-style apps, you can get a lot done with a simple web application using some of the new technologies. And so what I'm going to talk about today is HTML5 application caching. And this quote's kind of apropos. There's only two hard things in computer science: cache invalidation and naming things. And then there's an alternate view of that quote, which is there are only two hard things in computer science: cache invalidation, naming things, and off by one errors. Application caching is one of these things that seems easy when you look at the spec or you read some of the documentation, but what really happens when you start diving into it is you realize there's a lot of gotchas, there's a lot of really tricky things about it, and it's not as trivial as it looks or seems at first. So my goal here today is to try to give you a quick introduction to application caching, and also to kind of expose some of the gotchas, so that you don't make the same mistakes that we did at BusyConf. BusyConf is a company that Jim Garvin and myself co-founded, and one of the things that we use HTML5 caching for is our schedule. We publish schedules on behalf of conferences that work with iPhone, Android, iPad, desktops, and it is a link to the schedule. Any conference can link directly to it, and you get the full schedule on your phone. Now, the difficult thing with conferences is that you often lose internet connectivity, right? We've all been there. We've been at a conference where there's either your 3G connection's weak or the internet completely goes out, and so you don't have access to the things you normally would. But with application caching, as long as you've downloaded that schedule or that application once, even if you lose an internet connection, you can recover it, and it'll still work. I should mention that almost everything I'm about to regurgitate today comes from this resource. It's diveintohtml5.info by Mark Pilgrim. He does a really good job. There's an entire section of the book dedicated to offline caching. And if you haven't checked it out, I really recommend that you do. It's a really good read. So, application caching. The first question we might want to ask ourselves is, what browsers are supported, right? Well, the good news is that all major browsers are fully supported. Now, it's kind of disappointing. Even IE9 is not supported with application caching. IE10, though, should, according to the docs, I haven't tried it, but should have support for app caching. And when I say all major browsers, it includes all the mobile browsers as well, mobile WebKit and whatnot. So when we talk about application caching, it's important to know how it works. So the first thing that you need to be aware of is there's this file that you need to serve as part of your application, known as the cache manifest. And we reference the cache manifest in our HTML tag. In this example here, right, we specify the manifest, and here we have a mobile.manifest. You can name that whatever you want, as long as the extension is .manifest. And the more important thing here is that your MIME type, right, the content type for that file, manifest, needs to be served as text/cache-manifest. If you do not serve it as that MIME type, it will not cache in your browser, right? The app will still work, but when you go offline, it will not be cached. And if you monitor the logs of the browser, it will actually show you these errors that are happening because it's of the wrong MIME type. It's one of those pedantic things that not so sure why they wanted to enforce it so heavily, but that's something to be aware of and something you really should look out for. That manifest file is a plain text file that lists all the resources that HTML5 application needs to run. Okay, so every reference to JavaScript within the headers of your HTML needs to be referenced here. Any images, any other resources, you should list these all through here. Now, this example here is the simplest form of a cache manifest. The first line needs to be cache manifest. And then without any other headers or anything else, every other line just represents a resource that will be cached when you access the app. Okay? I'll explain what you can do to segment off the different sections of the cache manifest. I'm going to go through each different section. There's I think 3 sections, and I'll go through those now. There's the network section. The network section specifies everything that you want to access in your application, but not cache. Okay, in this example here, anything that we tried to access that wasn't listed in the manifest as in the cache section. By the way, if you have multiple sections, the cache section is what lists all the things that are going to be permanently cached. But the network section specifies everything that you want to access on the fly. These are the things, when you have an internet connection, these are the things that are going to be downloaded. This is really good for things like the resource that is used to send your analytics data, right? So that URL changes on every request, on the web bugs that are sending up through Google Analytics, for example, and that, by specifying a network section and specifying the things that are allowed to be accessed out while you're online, help with that. There's another section in the manifest. It's called the fallback. This one's confusing. We don't use it in BusyConf. It's not really apropos for us, but what it allows you to do is specify all the resources that you would like to cache if they are accessed while you're online. Okay, so that's a little confusing. So the point of it is to allow you, as you're navigating a web application or web pages on a site, to allow the browser, or to let the browser know that you would like these extra pages to be added to the cache, even though they weren't listed in the cache section. Where this is really good is in an app like Wikipedia, right? You don't want to list every resource on Wikipedia through the cache section. That would be crazy. But you might be willing to cache the pages that are accessed as you're navigating, right? So, oh, and I should explain how the syntax works. So on the left-hand side here is the pattern. That's the pattern that you want to match against for the resources that are that you're going to access while you're online. And the right-hand side is the resource that will be served if you're offline. So if you're offline, you don't have a connection, and you access this resource, in this particular example, the slash matches everything that isn't already listed in the cache. But you can specify per resource what you want to be shown in the event that you're offline. And you can have a different resource for each one of those things. And those things are cached, so that when you access them offline, you'll be presented with them. One really important thing to know about the cache manifest is that the browser will not update your application at all unless you modify the file. So the file that's served, the cache manifest file, needs to change if you want to update the app or serve new resources. One way we handle this in our application is we keep 2 timestamps that are always published as part of the manifest. This is ERB syntax. This talk was originally tailored for a Ruby audience, but it's any kind of substitution templating language. But what we do is we have some object that our resource represents, and we have dates associated when they were updated. So we always add that to our manifest. In addition, we like to list the date when our application was last deployed. That allows us to make sure that all caches are invalidated once we do a deployment. So just the key point to take away here is you need to update the manifest if you want your application cache to reset, to invalidate. The browser gives us some decent introspection into what it's doing through the cache cycle. There's a window.applicationCache object in JavaScript that you can access and inspect different events that fire to know what the browser's doing during the process of caching. And so this diagram here shows exactly the steps that the browser goes through. Now, the first thing it does when it sees a manifest file in your HTML5 app is it fires the checking event, right? That's to let you know that, hey, we know this is an HTML5 app, great. Let's check the manifest file, okay? So the browser's gonna download that manifest file. It's gonna make a decision. Was the manifest updated or not from the last time it saw it? If it's a new manifest, it's a yes. But if it's one that it's seen before, it might be a no. If it's a no, it fires the no update event. We now know that the browser recognized this application from a previous visit, and it will fire the no update event to signal to us that we don't need to take any action. It's cached, we're gonna serve the cached files, we're done, great. Now let's say the manifest is updated. It's changed, we've changed that date at the top.